So for this section, we're learning about this chapter and specifically learning about three dimensions. And this first section is roughly just going over a couple things. Mainly Euler's formula, which is calculate the number of vertices, faces, and edges in a polyhedron. A polyhedron is just a 3D shape on a 2D plane. Then you're going to describe cross sections of polyhedrons, and then you describe rotations of polygons about an axis. So the only formula you really have to know is Euler's formula, which is the number of faces plus the number of vertices is equal to the edges plus 2. And that's how you get this relationship right here. So the number of faces is pretty much the number of shapes that are in your figure. So in this case, we have two triangles, a square, and two rectangles, which means there's 5 shapes in total. The vertices are the edge points of when you connect the shapes. So in this case, we have 1, 2, 3, 4, 5, 6. And that's the number of vertices. So that's why it's 6, because it's the points at each of the cross sections when the two or more lines touch. And then the number of edges is just the edge of each of the figures. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So that's how we have 9 edges. This edges is kind of the hardest one to figure out because unless you actually have the 3D shape in front of you, or you can actually tell from the figure, it's kind of hard to determine what the edges are. So I would always recommend when you're trying to find edges to use this formula, but figure out the faces and vertices first, and then that will give you edges because you could just sum these up and then subtract by 2, and then you'll get your edges. So I'll recommend using this formula to find edges because faces and vertices are honestly the easiest one, but the edges might be a little bit difficult. Unless you're good at, modeling in your head. The next is cross section, is the intersection of a plane and a solid. The cross section of a plane and a convex polyhedron is a polygon. So for example, let's say you had a cake, right? And you use a knife and you cut that cake at this cross section here. And if you opened up that cake, what kind of shape would you get? In this case, you would get a rectangle. So that's what a cross section is. Rotation of polygons. So you're rotating a polygon about an axis forms a 3-dimensional figure with at least one circular cross section. So in this case, you start with a rectangle, right? And if you rotate it about its axis, you would actually get a cone. So it's pretty neat. This is used a lot in arts and crafts. So I'll show you guys a little quick video on what I mean. Let's see, which one's the best one? Mostly used in decorations. So let me, here it is. Okay, so you have this shape that you see a lot in party decorations. You get a half a circle. And all you would do is open it up and rotate it by its axis. So in this case, you would just open it up all together. Ta-da, you get a box. It's pretty cool. Okay, that's it. Okay, stop sharing. So that's pretty much the gist of when you do rotation of a polygon, you get a shape. So let me bring up back the notes. So let's get to the problems. Okay, so for for numbers 1, 5, and 6, describe the cross section of the figure to the right. So if you had a soda can, a cylinder, and you would cut it right down, I guess, horizontally, with the soda can laying down on its flat surface, you would get a rectangle. So you would get a rectangle, and that would be the answer. Can you go to the office and pick up a copy? Let me print out real quick. So give it a quick second. Okay, you're good. All right, so that's 1, 5, and 6. 2, 3, and 4. Draw the solid of revolution obtained by rotating the given plane region about the line L. So in this case, you have pretty much two squares, or a square on its horizontally with the base up and down. So if you were rotate it, there's two things that's gonna happen. One, you'll get a inner cylinder that's because it's not on the L axis, it's a little bit away from it. So that means when you rotate it, you're gonna have a little cone, not cone, a cylinder inside. But when you rotate it completely, you'll get something like this. So it's pretty much like if you had two, what's it called? What's the word? Two cones with a little cylinder inside. So that's what kind of 3D shape you'll have. You're not gonna draw it on the homework. The homework will have multiple choice, so you'll know which one is correct. So you'll get something like this. So I'll redraw it a little bit. So you'll have something circular. And then get oval. So that's kind of like the kind of a close shape you would get when you would rotate it. Pretty much two cones on top of each other with a little cylinder in the inside. Then you could just annotate it by putting a little. So you know that's the inside of the two cones. Number 7, so draw and describe a cross section formed by a plane intersecting the cone as follows. The plane contains the edges A, B, and C, D. So this pretty much says you're gonna cut that cube in intersections of A, B, and C, D. So in this case, you have A, B here and C, D here. So that means if you want a cross section, you're gonna cut that cube like if you would cut a cake. So in this case, you would actually cut that intersection diagonally. And the intersection that you would get is a square. Or no, in this case, it would be a rectangle. So you're gonna cut that square cake diagonally. Because you need the intersections of A, B, and C, D. And you'll get a rectangle if you open up that piece of cake. Does anyone have any questions? Okay, so it's 7. All right, we're almost done. Number 8 and 9, you're gonna complete the table, draw a net of solids. So you're gonna label the number of faces, the number of edges, and the number of vertices, and then how many squares make up that shape. So the number of faces. So you know this is a die, right? So how many sides does a die have? 6. So there's 6 faces because there's 6. There's 2, 1 left, right, up, down, left, right, up, and then front and back. So the edges we'll do last. The number of vertices, you're gonna count each of the edges, each of the points in which the lines touch. So So you have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 vertices. Now you could, if you want, color code it so you can see the number of edges. So in this case, if I would do it, you can just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's actually 12 edges. If you didn't want to go around and actually label them, you could just use the formula and that'll give you the number of edges. So there's 12 edges, 8 vertices, and 6 faces. Does anyone have any questions? And honestly, this is just used if you would actually try to redraw it yourself. So if you try to redraw the cube, you will draw 8 vertices, right? So 1, 2, 3, 4, 5, 6, 7, 8. And then all you have to do is connect the edges. So it's not going to be a perfect square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not perfect, but that's just like the whole gist of why the number of edges and the number of vertices is important. Does anyone have any questions? So the number of vertices and edges helps us to draw a 3D shape in a 2D plane. Next, how many squares is this cube made up of? The answer is 6. There's 6 squares. So drawing a net you learned in math 1, it pretty much says, how can I draw this 3D cube on a 2D plane flat on its surface? So you would have something similar to this, right? We have 1, 2, 3, 4, 5, and 6. It's pretty much a foldable. If I wanted to, so if you would draw that cube on a 2D plane, flat on its surface, you would have something like this. You cut out the piece of paper and then you would fold it with all the edges and vertices connected, and you would actually get a cube. So it's pretty neat. Does anyone have any questions? Okay, very last one. Number 10 says draw a plane intersecting a cube to get the cross section indicated. So in this case, you will cut that cube somewhere around the cube to get a scalene triangle. So you should know a scalene triangle, no sides are equal. This first intersection, if you would cut that cube along those lines, you would get an isosceles triangle. These two sections are, sorry, these two segments of that triangle are actually congruent. So this is actually a isosceles triangle. This one, on the other hand, you'll have this diagonal line, and then this diagonal line. This is an equilateral triangle. All the sides are exactly the same because you're going from one edge of the square to the other edge. So this is equilateral. And then the process of elimination, the only answer for this would have to be this one right here. Which you can tell that none of these side segments look, it's not even close to being similar. So this would be a scalene triangle. All right, so the homework is already posted on Canvas. We'll do 13-2 tomorrow. And then you guys can get started on your homework.
I know I'm doing that like. So I got this one. Yeah, the little. This is for. This is for. This is for. This is a. So that's why I was in my. Oh, okay, what card? We're gonna gamble. Like, I don't know, there's a lot of games that are gambling. The one who likes this one. It's like slot machine gambling, but they don't have any hands on. Well, I say, since you know all the games that are card games are huge. What? I don't know, I think those. Well, you can blow up the slot machine, that's all that's cheating. If you might get like some points. There's also like one singular item that gives you better gambling. It's like horse clicker type two. Horse clicker type two. There's horse clicker type two. Yeah. There's like yeah. Okay. It's like actually a lot of games. So like how it works is there's like it's just like you buy like horse eggs and it hatches into its horse yeah, no, it's weird. But it's like and then they should not put horses and then you can send your horses the play goes random. So it's all game. There's one character. Yeah, he starts with lucky foot, which gives you better chances. There's not really everything so when you started out. Oh yeah. He starts with an item that gives you better gambling chances. This is like the gamble character. I understand. What else does he do? Is that it? Actually, I can't remember. No, I don't remember. He has lower health. Yeah. He also speed. All I remember is it. I'm not a real video, I think. Lincoln, I drew your little guy. He has increased speed. Yeah. So cool. Oh, he has a paper. This one, sorry. It's a trinket. It's a open box.
I'll have the.
Yes, trinkets are actually like a big.
That's it.
I think you guys should gamble, maybe. What? They drop them.
They dropped them, he dropped them.
Whatever, man.